So geniuses, let's take a look at some geometric sequence problems. What makes a sequence geometric is that we need to be constantly multiplying by a same number or a same ratio from term to term. For example, 2, 4, 8, 16, 32. Each step of the way we're multiplying by 2. Okay, they're claiming this is a geometric sequence and we're supposed to find the first 5 terms. Hopefully we recognize this type of a structure or this type of a definition as being recursive. There's a vocabulary word for the day. A recursive definition generally tells us what the first term is and generally gives us a structure involving a sub k plus 1. A common mistake in my mind that people make is that they read this as ak plus 1 equals 1/3 ak. I would rather read this as to get from a given term to the next term, we multiply by 1/3. In my mind, I see recursive definitions as a ladder. In this case, the first rung on the ladder is 81, and we need to step up to the 5th rung of the ladder. This recursive definition tells us that to get from the first term to the second term, we multiply by 1/3. So 1/3 of 81, 27. To get from the second to the third, we multiply by 1/3. 27 times 1/3, 9. 9 times 1/3, 3. And 3 times 1/3, 1. A more algebraic approach to this would be to say that A2 is equal to 1/3 times A1, the term that precedes it. In this case, of course, that's 1/3 times A1, 81. And that starts the ball rolling with our second term, 27. Now, for the nth term, we're going to take a little look here at our sequence, which we discovered was 81, 27, 9, 3, 1, and clearly we divide by 3 each step, or maybe more importantly to see, we're multiplying by 1/3 each step. Repeated multiplication, such as 7 times 7 times 7 times 7 times 7, would be nicely grouped with an exponent. So we're going to want to put an exponent on 1/3. So I'm going to set up the nth term formula as an equals our first term, 81, times 1/3 to the, I need an exponent to go with this 1/3. And it's very tempting to put n there, but to get from 81 to 1, to get from my first term to my 5th term, it took 1, 2, 3, 4 multiplications by 1/3. So to get to my 100th term, I would have to multiply by 1/3 99 times. To get to my nth term, I have to multiply by 1/3 n minus 1 times. And there is our nth term.